Hey everyone, CTF Radio here with a very special episode. It is currently day 2 Saturday of DEF CON 32. I have with me Zardus.
Hello, hackers!
Wow, what a catchphrase, man. When you hear that phrase, it really gets you in the depth of your soul.
That's right. You can start learning. It opens your mind.
Well, for me,
it's like
it
you hear that, it's instant inspiration.
Instant inspiration. So, as you may notice, we have 2 very special guests with us on my left. So we have Clasm and Honolulu. They are going to be talking to us about the AIxCC challenge, as we had mentioned on previous episodes. They're also co-captains of our AIxCC efforts. Clasm, let's start with you. Talk a little bit about the approach to AIxCC and your background slightly, so you can introduce yourself to our lovely audience.
Yeah. Hey, everybody. My name's Clasm, Will. I'm a PhD student at ASU and the captain of our CTF team, Shellphish. I've been competing in CTFs since 2016, maybe?
Without using IDA.
Without using IDA. That was I was forced by this man sitting over here to only use object dump for maybe 5 months before he would let me have a taste of a decompiler.
I feel like I've heard this story more than once today.
It's a poison that spreads.
Nowadays, that would be illegal, but back then it was
I think that's considered normalized abuse.
You gotta walk before you can run. You don't see people sprinting out of the gate.
Yeah,
you gotta do that first.
Yeah, sometimes I think that's great, sometimes it's nice.
Also, repeat guest. You were on our DEF CON episode last year.
That's true.
In the tub with us.
If you recognize me from the tub, I'm Tubman.
Wow, great.
Man, the hot
we'll bleep that part out.
You edited it and bleep it out.
The hot tub streams made it to the CTF team.
So Lucas, what about you? What's your background like?
Yeah, I've been playing CTF since 2013, 14 maybe.
He's old.
Ouch. You're not wrong. I played in my old team in Germany, in Faust, for 2 years, and then I went to UCSB, did an internship there, and then just kind of started my PhD from there. I've been just, building symbolic and concolic executors, dabbled a little bit in fuzzing, and just in general now kind of just like experimenting with LLMs and stuff.
Awesome.
So
great. All right. So let's set the stage back 1 year ago. So if I recall correctly, it was at Black Hat last year where Perry Adams announced the DARPA AI Cyber Challenge. And then what did you tell them to do? Were you involved in this story?
Yeah,
he was involved.
So,
So
I reached way back, right, into my experience in the Cybergrand Challenge. And you caught the tail end. You caught the tail end of the Cybergrand Challenge or right after?
Well, I got to enjoy the benefits of the Cybergrand Challenge. I didn't participate.
You got to spend
but I got to go to the retreat.
That's right. That's good. All right.
I was involved,
Yeah. So, well, that's, it's important. You gotta spend the prize money otherwise. The Cybergrand Challenge was a massive undertaking, right? And building these incredibly complicated systems. And the biggest problem we ran into is there was just a lot of moving parts in the CGC. We had scaffolding and we had these individual components. They had to talk to each other, but they also had to be resilient, and they also had to adapt to different situations. It was insane. And so my very, very strong advice for the AIxCC was, hey, let's start out with the smallest, simplest cyber reasoning system we can possibly think of. And then we go from there.
And that's what you told Will a year ago?
That's what I told Will and Lucas about a year ago, yeah.
This is obviously what we did.
This is what we did. As I remember, actually, it was right after DEF CON finals of last year. As all great messages start, I get a, yo! From Zardus. And he's like,
is that boomer slang?
That's boomer. That's
not boomer slang. All right, for the record, I used to play this very awesome game called Gladiator. It was wait, don't laugh like you've never heard of this.
Does it sound like a
awesome
cuniform tablet or something?
No, it was on AOL
CRT?
downloads. I got it off the AOL download section.
Wow, not LimeWire? That's okay.
No, that was a gleam in someone's eye back then. No. AOL downloads. It was a shareware game. It was the first game I actually registered. Actually, I lied. It wasn't AOL. It was rocketdownloads.com. No, but I registered. Anyways, it was an awesome shareware. Amazing game.
So is this like a 5-minute story about why you use the word yo?
Yeah, the basic idea.
I didn't get that.
Basic characters in the game said yo, and so now I say yo.
Okay, amazing.
Okay, so you started a message to Will that said yo.
Yeah.
Here's like the rest.
What do you think about competing in AICC? And I was like, what's that? And he was like, think about the CGC. Okay, but the second time.
With AI.
And with AI, with LLMs, and he, as Zardus tends to do, sold it very well to me.
Well, you gotta think about it too. It's not the CGC a second time, because there wouldn't really be necessarily much of a point unless something fundamentally changed.
Yeah.
And that fundamental thing, excuse me, that has changed is this modern generation of ML systems.
Yeah. Yeah, and that's kind of like, I think the initial kickoff point that made it interesting for me is like, you didn't start out, like, CGC was cool, but it was all very neutered. It was all very, like, constrained to small, manageable problems that, like, they built their own operating system with very little operations. And it's like, that's cool, but there's a reason that none of the, or most of the cyber reasoning systems really didn't live past the end of CGC.
Yeah,
that's a good point. And not to say that like CGC was simple and
no, that not at all. But it's just like the level of maturity of the tools and stuff was just like a lot lower.
Right, it was a nice like proof of concept that this could be done and showing how you could do this, but there was a giant gap between like taking those results in, because people at the time thought like, well, these cyber reasoning systems are going to take over the world, find exploits, and we're all dead and whatever. But like, there was a giant gap that you can clearly see, because that's still not a solved problem.
Yeah, and then they were like, oh, we're going to run this on real software, and we're going to make this actually find bugs in real programs. And we were like,
and when they say real programs, that was what they said. And then what was the first
program? Yes, I was about to get to that. I was about to get to that, which is like, we're like, oh, that's cool. We're gonna like we're gonna fuzz C programs, and that's gonna be cool.
I want to interject really quick, which is, as Zardus suggested, we initially built on small to medium-sized open source software a fully end-to-end functioning CRS.
Yes,
and we cannot be faulted for that.
That's good. That's true.
And then it was December 13th-ish, 12th maybe, like around that time, and they give us the first slate of preliminary rule suggestions and the first exemplar target. And the first exemplar target was the entire Linux kernel. And if you don't know anything about the Linux kernel, here's a point of reference. I think we counted the lines of code in it. There's like 1.8 million, I think.
Yeah.
How long did it take you to count them?
A lot of bash scripting.
Use grains of rice and lay them out one at a time.
There's an abacus involved.
Exactly, You should know from your gladiator days. That's how you keep score.
For the record, that game wasn't about the, like ancient, and it's not important. All right.
No, that's Zardus' old joke.
Yeah, and I mean, for reference, the applications we were testing on before weren't necessarily small. They were parsing like image file formats and stuff, but that was like a couple thousand lines of code. This was like 3 orders of magnitude more than that.
Okay, so this is great, and I think this gives some intuition, and I think maybe even Perry mentioned, because she was on the CTF radio thing a year ago when they announced that, talking about this, like they really wanted stuff that would work on not just real-world targets, because the things you were testing on are real-world software that people use every day, but it's very clear they want to target critical infrastructure that, like, because Linux basically, I mean, you find if you found a remotely, fully kernel exploitation on the Linux kernel, we're talking massive, widespread damage.
Yeah, a decent amount of the internet cloud, like
exactly.
Something like 70-80%. I think it's insane.
It's crazy. So so like I think that, at least from my perspective, I definitely saw that, like, oh yeah, DARPA's like actually like they're not just like, hey, you're gonna do this stuff, but you're gonna really do this stuff.
Exactly. That was one of the really cool things, I think. Like, obviously there was a lot of despair when we heard it announced, but initially, running on these targets, we were a little happy-go-lucky. We were like, oh, we're finding bugs. This is cool. We have a nice system. Yeah. And then they hit us with the Linux kernel, and we're like, how do we even do this? How do we even start to approach this topic? Because it was just so much.
So you took those new targets, and you adapted your end-to-end system to continue to be end-to-end and work on those targets.
Well,
I mean,
it was an end-to-end system that didn't work.
Well, so the funny part about that is, I don't know, maybe this is just me, but if I remember this correctly, I think for the first 3 weeks, we were just kind of did nothing on the kernel. We were just we're going to pretend to ignore that this happened. We're going to keep building our system that we know how it works. And then we'll get to that bridge we'll cross that bridge when we get to it.
And then pray that there'll be another challenge problem that's similar to what. And I think maybe if you can talk, because we have limited time here, but talk briefly about for maybe people that don't know this, they're oh, but if you're able to find bugs and fix things in small to medium-sized program, yeah, I understand the Linux kernel is super large, but why does that scale mean that you can't just apply that system to the Linux kernel?
Yeah. I mean, go ahead.
Oh, I was going to say, there's a couple different issues with generally with smaller to medium-sized programs. There's actually very well-defined inputs and outputs that can go into these things. It's relatively easy to identify you got sockets, you got environment variables, you got argv. But with the Linux kernel, you have every syscall that exists. You have the network stack. You have interrupts that happen, and all of these are very complex and worthy of their own small system to try and find bugs in themselves.
Yeah, and I think another part of that is when you have these smaller libraries or things like that, they have one very well-defined purpose, where I can look at every single file and kind of get an idea based on what the overall thing does as to what will this file do. But then you have the Linux kernel that just has everything as this giant monolithic thing, and you're trying to find bugs in everything at once, which normally you might use 7 different approaches to solve each of the smaller targets.
Yeah, so it's interesting. So it's almost like a different modality of interactions, right?
Yeah.
It'd be you planned on, testing a car, and they gave you a jet.
Yeah.
And you're yeah, technically it's a transportation device, right? But it's completely how you go about testing it, the different stresses that are under is completely different, right?
Yeah, or I mean, at some point, a city, right? All of a sudden, you're trying to debug multiple buildings at once, and you're I know how to analyze a wheel.
Yeah. Well, one of the big problems we were solving, kind of near the end of the competition, maybe we should have solved a little faster, is the Linux kernel is huge and actually takes a ton of resources to build.
Yeah.
And with small to medium-sized programs, those things, 30 seconds, maybe a minute or two at most. Linux kernel will run you 30 minutes if you're not well prepared to handle it.
Perfect.
This is also super the case if you're making patches and then need to recompile it.
Okay, great. So then fast forward a little bit. So what was then the next different type of challenge problem? The next curveball that DARPA threw your way?
Yeah. So after the Linux kernel, DARPA teased this a little bit. We had no idea how it was actually going to work out, but we had Jenkins, the big CI/CD Java-based platform, and we're how do we go from this figuring out of doing memory corruption stuff that we're thinking about for the Linux kernel, and now we have to deal with potentially XSS, CSRF, just totally entirely different worlds of vulnerabilities.
Yeah. And so how did the team, was it another 3-week just freeze of well, just think about it. That's a classic PhD student thing.
It's
professor, research. Yeah, I got to think about it.
Yeah. No, so I think with this one, they had, Will said, they'd already teased it a little bit of, hey, the Jenkins will be a target going forward, but we hadn't seen the target yet. And so we started building, even before that target came out, we started building Jenkins-specific tools on our own versions of the Jenkins target that we had made to test with. But again, we kind of didn't think big enough. We thought we were going to find bugs in Jenkins itself as one piece of software. But then the exemplar came out, and we actually saw it. Really what we're finding bugs in is plugins in Jenkins that are hooked into this complex infrastructure in very specific ways to how Jenkins operates. And then we weren't looking at bugs in, Jenkins was still in scope, but the main thing that we were given as an example was in these dependent pieces of softwares on Jenkins that are tightly coupled. So now a lot of the work we'd done before was we have to pivot, right? We have to find some other way of analyzing this and some other way of finding these bugs. And so we started building tools for that. And I think one thing that was good about that target was that because of the way it was harnessed, DARPA gave us a relatively easier entryway to start analyzing it. Because it was already built with that specific fuzzer in mind, which we had intended on using anyways. And so then a lot of it became about, okay, well, how can we make it find bugs? How can we make it solve roadblocks? How can we make it as general as we can?
So then there's, and I think, correct me if I'm wrong, but there were basically 3 different types of challenge problems, right? So like C-based stuff that you actually already started with, but I don't know, the complexity of the challenge problem they gave us was Nginx, the web server, which is a giant, massive piece of software. So you have, even in your cases of small to medium-sized C programs, the example was actually like very complex and very large. So you had those types, and then you had the Linux kernel as a type, and then you had Java-based, not necessarily Jenkins, but Java-based challenges. So how do you go about building a cyber reasoning system that can tackle challenges in these 3 domains?
That's a great question.
Without giving away any secret sauce, I should say, obviously for the listeners, we don't know. We're in a quantum state right now. We don't know if we've qualified yet or not. And so we don't want to talk, the team, I'll let them decide, right? But they may not want to talk about all the details of exactly the system, just in case that may be useful.
I think like the one approach is first, you have to find like all the commonalities, or how to make all of the targets have commonalities of these things. Like, how do you do static analysis on these targets that's then also representable to like further components, but is in like a unified format, right? That was one thing that we had to tackle. And then what's interesting is LLMs actually helped us out a ton.
I was going to ask. I've saved that question of how LLMs actually helped. But yeah, if you want to touch on that, that'd be great.
Yeah. Our patching solution is entirely LLM based. And that's amazing because it means that we don't actually have to think about the differences between the languages. And another great aspect of this is that because these are large, well-known programs, the LLMs themselves also are trained on them. And if you play around like a little bit, if you look at these big targets, you'll notice you actually get very well-formatted output that is, or like calling methods or using structures that are internal to that program that you actually don't give the LLM like direct advice or notice to.
So it knows how to write Jenkins plugins because it has trained on the documentation, and so when it sees your plugin, you're trying to fix a specific bug. But you do give it analysis. It's not just LLMs. They need the bug input. And presumably you get them some other good stuff that I don't know if you want to talk about.
Yeah, that's a tough one because that's like a bit of our secret sauce here. Yeah. But I will say that trying to use LLMs to also find these bugs was a very interesting challenge. And not very straightforward is maybe what you would think. Like,
I was going to say, the interesting thing I think of what I saw from what you guys did was have a pretty good testing infrastructure to try out. You essentially did some stochastic exploration of the state space of possible ways to do patching strategies, but then being able to systematically evaluate them to see which ones actually were good for the targets that you like.
Yeah, I think one thing that definitely helped was having also for the LLM input, right? Where it goes a little bit back to your initial question of like, how do you make this work for all of these different targets? But one thing that we lean pretty heavily into is like a conformance to a shared schema in the information that we internally process, right? We try to keep it as language agnostic as possible. And even though we started out with separate pipelines, at the end we have one pipeline that handles all targets. And one thing that specifically the LLMs we found is the quality of the data that you give it and the amount of data that you give it is very important when it comes to like what outputs it gives you. So sometimes you can give them the crash report of the crash, and then that's really good. But other times they need some more information from outside that we can feed it to really have a good chance of finding the bug.
And sometimes you forget to feed the LLM data, and you end up with the LLM telling you that you have a Java vulnerability in your Linux kernel, which is very difficult to manage and took a couple hours to figure out.
And this is kind of interesting, right? So the LLMs, you were leveraging the fact that because they were trained on a vast quantity of data, actually some of that data was your targets, which actually makes sense in the context of this challenge, because DARPA wants to build systems that can help open source developers actually like fix bugs automatically. So it makes sense that those models would train that. But on the flip side, you're going to deal with insane hallucinations and other things that the models would just randomly do.
Yeah. Like exactly like Lucas said, if you get in almost what you put out, if you're able to constrain the problem well enough, and then maybe a little bit of luck on your side too, you can actually get very reasonable output from LLMs. But we're also like kind of noobs at this LLM stuff. You know, first and foremost, we're binary analysis people. We didn't have Wenbo Gu from UCSB, our beacon of hope in our LLM process. But yeah, we tried a bunch of stuff. We found really cool techniques. You know, we tried tree of thought. We tried chain of thought. We tried, you know, making a bunch of agents and stuff. We tried a whole host.
The Russian roulette of experts.
The Russian roulette of experts. That is
secret internal thing.
Yes.
You don't even know about it.
I don't think that's quite safe for work.
Yeah, we didn't want to say it in front of you. I don't know if it's like racist against Russians or something. So I didn't want to.
I will say one key success. We had a lot of hackathons. Having a great hackathon requires Zardus to explode an egg in a microwave.
Oh my god.
I think like that would kill Lucas literally. So
It almost
probably,
did.
I know it's probably not the greatest. But
I don't know.
The egg shouldn't have exploded. I understand that
we actually went over this
that,
on
Yes.
the last
that
episode.
field
You can
egg
see
should
the-
have exploded, but
You can see the
I
video.
maintain that was a bullshit situation.
I
I'm
see.
still not quite sure what's worse, the egg or the bees. I'll take.
The bees were something too.
Maybe the egg attracted the bees.
The
Yeah.
leak was, anyways.
Yeah. So okay, great. So we got 5 minutes left before we all have to run. Unfortunately.
Let me ask one question that's been on my mind. What's the biggest surprise in the process?
What I was gonna say, but you can let me finish. That's fine.
I'm sorry.
It's
Go
okay.
ahead. Like, you ask it. You ask it.
No, you already asked it.
No, it's fine.
okay.
It's fine.
You just gotta steal my. I'm the host. It's fine.
That's good.
We're good. We're good.
Why don't we have Will ask?
Yeah.
Okay, what was the biggest surprise you think?
The biggest surprise for me,
Besides the Linux kernel.
besides the Linux kernel, was something. Well, okay, I'm going to name two because one should have been obvious. The other one wasn't
great.
obvious. The one that should have been obvious was how much time it took to get everything to the base minimum state of anything working
Right at
at
the
all.
beginning.
And the thing that was less obvious to me was, at the beginning, I was very negative on LLMs, and I still, to some degree, I think there's a lot of problems with them.
Healthy skepticism.
But they can be, one thing I've noticed is they can be surprisingly insightful, and really what all of this is about is finding some way to distill that insight in some kind of purpose where you can detect when it is giving you good feedback versus when it is giving you nonsense, and building your system around that. And that can really actually be quite helpful.
Nice.
Yeah. I mean, to piggyback off of that, you know, we've had times where LLMs really surprised us. We were able to, we had like a variability in the amount of time it took us to find one of the example Nginx bugs, because we just got lucky sometimes, and the LLM knew exactly what it was talking about. And then sometimes it gets it harps on one like wrong piece of information. It just goes down an entire rabbit hole. And your entire system. So a lot of it is also putting up, you know, like guardrails around it to make sure that it can go a little crazy. And sometimes it's great for it to go crazy. Sometimes you produce like better patches by letting it go a
Sometimes
little
you
crazy.
need a temperature greater than 0.
But not greater than
Our
1.
secrets.
Not greater than 1. Then you start getting Latin, and that's not good.
I mean, maybe it depends on who's using the CRS. So,
That's true.
The Pope?
I mean,
Maybe the gladiators.
we have CTF radio listeners and guests that are very big.
If you speak
proponents.
Latin, I'm glad for you. That's a great accomplishment.
All right. Well, I wish I had a good any more closing thoughts of like, can you distill maybe your experience over the last year in like 1 minute to convey to our listeners?
Straight insanity at every single step of the way. We were surprised both by ourselves and the competition. We were able to make some really cool stuff. We had to throw some really cool stuff out that just, you know, we thought would work, but didn't. I think that this is like definitely a good step in the right direction for like merging LLMs and security.
I think for me, I would say, I think we've had a lot of experimentation, like most of the last year, partially because we're still waiting for information, partially because we're experimenting with things. We've thrown out so many things that were so promising when we started. Some of them came back. Some of them are gone forever. Some of them, hopefully, we'll be able to bring back for finals if we make it. And I think it was just a really cool process to see that we built something that at least was able to find one bug that we know of and patch one bug that we know of. And I think the system as a whole, and just kind of these systems in general, really do feel like they can work in the real world and like work on real pieces of software and make them better going forward. So that was really cool.
What would be your advice to the next generation cyber reasoning system contest?
When you become a professor
right.
and you have students and they are your students and then you will be their
And we are
professor.
I see.
I mean, so the obvious advice is don't listen to your professor.
If you build an end-to-end system from the get-go, it's probably not going to work. That's really what I learned. That's the knowledge.
I guess that's good feedback, you know?
But in terms of the actual answer, I think not being too afraid of throwing out the stuff that you've worked for 2 months on because, hey, the ground shifted underneath you, or like things break and that's fine, and you'll make something else and that's also fine, and you're going to be okay at the end.
Okay,
No,
final.
you didn't answer.
Oh, you
No,
didn't
We're
answer.
done after this.
Yeah.
That's good. That's
Actually, it's fine. Let's hear Zardus's ending statement. I forgot what the question was. It's fine.
All right. The final question then is, when we 1.5 million whatever total in the CGC, we went and had a crazy rager in Hawaii, a workshop to develop cybersecurity
Of course.
techniques and knowledge in Hawaii.
With the foremost experts,
Exactly.
of course.
What are we doing?
I mean, that sounds like a great plan. It sounds very educational, very fruitful, and like a blast.
Hawaii? Hawaii too?
Hawaii too.
All right.
Sounds like a question for tomorrow.
Yeah, when we find out. So we'll know by the time this is out, so hopefully we'll either be crying or laughing by then.
Yeah,
We'll do a follow-on episode with just that.
15 more minutes
sobbing.
of sobbing. Or,
Yeah.
So
Either
please,
sobbing or in Hawaii. Like,
root for our curse team Shellphish. Our system's name, which you didn't mention, is ARTIPHISHELL, as you can see on 3 of our 4 shirts. Thank you all for listening. And are you going to let me finish? Goddamn episode? Okay.
Hello?
Not
See what it's
again.
like? See what it's like? All right. Thank you, everyone. Appreciate it. Goodbye.
Bye.
Like and subscribe.
No, we don't say that.
Oh, we don't say that. Don't do it.
No, dude, I mean, don't tell him not to.
And now we go to the DEF CON closing ceremonies where we find out if Shellphish made it or not. ... The suspense is killing me. ...
I take it there are some shellfish wolves in the ground.
Your software engineering approach was ambitious.
All right, we're back at CTF Radio. Oh my God. And the qualifying teams have just been announced. You can see I'm much more out than before. So guess what? Did we qualify? Yes. Yes. All right, now let's
Say goodbye.
we say goodbye. No, we need our interview, our guest. Yeah. All right. Tell us.
What does it feel like?
I have no idea. I can't feel anything.
It was so stressful.
What do you think was the critical secret to success?
Blood, sweat,
Announcing the
and
names
tears.
in alphabetical
Yes.
order. That was good. That was.
Kept the hope alive.
Oh my God.
All right.
I have no idea.
There we go. Cool. All right. Now
Now it begins.
Now it begins.
See you next year.
See you next year.